All right, grade 11s, this is the second part of your grade 10 revision for analytical geometry. It is the revision of parallel lines and perpendicular lines. So if you have parallel lines, those lines are going to have the same gradient as each other. All right, so you work out their gradients and they'll be equal. That's because their slopes are always going to be the same in order to keep them the same distance apart forever. That's the definition of a parallel line. And then for your perpendicular lines, it is a relationship where your gradients multiplied to each other get you an answer of -1. So if you get that relationship, then your gradients are, not your gradients, your lines are perpendicular to each other. All right, so let's go through a simple one and then we can go through a more complicated set. So for 2.1.1, prove that the following two lines AB to CD are parallel. Now they've just given you different combinations to work with here. So in each of them, you've got to work out the gradient of AB and then the gradient of CD. So that's simple enough, and so I want to focus more on your setting out and how you're going to conclude that they are parallel or not parallel. So for point A to B, we're going to use our y2 minus y1 over x2 minus x1. You don't have to write the formula out in maths. You can just go straight into the substitution. So I'm going to have 0 minus 3 over 3 minus -6. So my gradient there is going to be, that's -3 over, that's going to be +6, so 9. So that's going to be -1/3. And then your CD, so gradient of CD is going to be the same process. So you're going to have 4 minus 5 over 5 minus 2, which is going to be 4 minus 5 is -1, 5 minus 2 is 3. So therefore you've got your two same gradients. So now you can conclude. Therefore, the M of AB equals the M of CD. Therefore, AB is parallel to CD. So we'll give you a mark for working out AB, CD, bringing them together, and your conclusion. All right, so please show us all the steps. It's easy marks. Okay, so you can do the rest by yourself now. The aim is, because it said prove, that you're going to get the same gradient. So make sure you get the same answers, otherwise you've done something wrong. All right, then again, prove that the following two lines, DE, and FG are perpendicular. So DE and FG, so they're not parallel, they will be perpendicular. So let's work with the gradient of DE and then the gradient of FG. So the gradient of DE is going to be 5 minus 10 over 6 minus 8, which is -5 over -2, which is 5 over 2. And then FG, 11 minus 9 over 2 minus 7, is going to be 2 over -5. All right, so hopefully you notice that the one is positive 5 over 2, the other one is -2 over 5. They are additive inverses of each other. One is positive, the other is negative, and then they flip. And the reason for that is, now this is how you'll set it out, therefore, gradient DE times the gradient of FG is equal. Now you don't know it's equal to -1 yet, so you first got to show us. It's equal to -1, therefore DE is perpendicular to FG. All right, so just ignore that parallel line there. For all of them, prove that they are perpendicular. And then it says the quadrilateral is given with the points A, which is -8 and 3, and then B, I see, should be 0 and 3, not 3 and 0. And then you have C, -1 and -6, and D, -9 and -6. So determine the gradient of AB, okay, and then determine the distance of CD. And then Once you have finished this, then you can mark it using the memo that has been given in the slides, and then you've kind of recapped your grade 10 analyticals. When we see you in class eventually, we can move on to just finishing up the grade 11 analytical, which is quite quick and not too tough at all. And then we just put it all together.